last week. It's on Google Classroom. It's posted there, and I'm also putting the link in the chat. So if you guys could give me a thumbs up once you're on the Google form, so I know everyone's ready and doing it. Was everyone able to get on the Google form? Yes, no? Okay, could you guys message me in the chat if you're not able to, and I will help you out. Okay, we're waiting on a few people to turn in the quiz, and then as soon as they do that, we'll start today's lesson. Okay, great. I think that everyone has turned in their quiz now. Okay, so then we're gonna start our lecture for today, and it's on the states of matter. Do you guys know the three main states of matter? And if you do, can you type them in the chat or unmute yourself and let me know? Okay, yeah, I got a response, and the three states of the three states of matter are solid, liquid, and gas. Yeah, plasma is also a state of matter, but um, it's kind of a complex one, so I think we're covering that in our next lecture. And today we're discussing solid, liquid, and gas. Okay, so we're going to talk about the three states of matter. And so, okay, what is matter? Before we start discussing the three states, we have to know what matter is. Matter is anything that takes up space or has like a weight, a mass, and it takes up space. It's everything that we see in the world around us. And everything you like, so the computer you are using, the device you're using to sign on to the Zoom meeting, that's matter. Matter is anything that you can touch or you can see. And so we're going to talk about solid, liquid, and gas. So first up, we have solid. So solids are characterized by their definite shape and volume. And okay, so when you look at a solid, like a rock, for example, a rock can't change its shape. That means that it has a definite shape. And
So the rock has has a forever shape until something breaks it, because you can break rocks.
yeah, exactly. The change won't, the shape won't change by itself. It will change with an external force, though, which is like breaking the rock. And also, like shape, the volume of rock doesn't change, right? Unless you do something to it. Um, so in a solid, particles are really close together and they have strong forces of attraction. So that means if you look at this diagram here, we have a solid and you can see all these little dots are atoms. All of these atoms are packed together, right? They're arranged in a formation. That's a characterization of a solid. They're all attracted to each other, so they all pack up together and make a nice shape. So that's the solid. The liquid state has a definite volume. So water, for example, if you have a glass of water, the volume of the water won't change, but if you place the same amount of water in a different container, the shape will change of water, right? It takes the shape of the container. So, like you can see in this diagram, the particles of liquid, they're still attracted to each other because they're close to each other, but they don't have a shape anymore, which is what allows them to change shape into any container that they're in. Do we have any questions on solid and liquid? No?
Okay. So a liquid. How is a liquid formed?
A liquid is a bunch of molecules. So a liquid H2O, water, for example, is a bunch of atoms that form to make a molecule, which we talked about last class. So when they form to make the molecule, these molecules are all attracted to each other. So they form bonds and they make like water, for example. And every liquid has different has different compounds. Like for water, the compound is H2O.
But how is it like not close but not touching? How is it like that?
So what happens is the attraction between the liquid molecules is less than it is for a solid, which means that it's still attracted to each other. So it's going to be in like the same area, but because it has less of an attraction, they won't like be very close together. Okay. Any other questions? Okay. You can always type them in the chat if you do have questions. And the third state that we're going to talk about is gas. So gases, as you can see, have no shape at all. The particles they have very weak attraction. That means they're barely attracted to each other, so they have no shape and they have no volume. So, for example, if you have a gas, like a little bit of gas in the container, the gas isn't going to stay in one area, it's going to spread out all over the container, which means that its volume and shape always changes. And the particles have weak attractive forces. And common gases are like oxygen, carbon dioxide. Any questions on gases?
Huh, but doesn't air like and carbon dioxide take up a room? At like some point, there's so much of it that all the solids, let's just say example, can't go in. So the gases stay around, but they don't change shape unless something opens the door or something like in a building. There's a lot of air.
Yeah, that's correct. So, like, for example, if you have a bunch of gas in a container, the gas will stay in the container and will take the shape of the container, but unless you open the container, it's not going to leave, or unless there's any leaks in the container. Any other questions?
Water can also leak and lose its shape with a leak also.
Yeah, when water, but water, like the molecule, if when like water or any liquid, it can change shape like a gas can, but it's more attracted to each other, which means that the volume doesn't change of water. If you have water in a glass, for example, and you move it into a different glass, the volume of water will still be the same, but the shape will change. Does that make sense? Okay. Again, you guys can put any questions in the chat. Okay, so more about the solid state. Like we said, solids can maintain their shape and their volume. Doesn't matter what they're in. If you put a rock in a container, it's still gonna have the same shape and volume as it will outside of the container. And solids are basically everything we see. What buildings are made out of, concrete. What if you have a desk is made out of is a solid. And within the solid, the particles are very closely packed and they have a really strong attraction. Um, and that means that the solid can't move around freely. The particles of the solid can't move around freely. And then solids, and examples of solids are like ice cubes in your freezer, the wood that you see on trees or on a fence or on
But
your house.
okay, so an ice cube can be all three states of matter. First of all, it can be frozen, which is the solid state. Then when it melts, it's water. Then when it evaporates, it's gas. So isn't
Yeah.
it a little mixture of both, but it's just made out of water?
Yeah. So we're going to talk about this a little bit later on, but water is a very a cool like element compound, and basically it can exist in all three states of matter depending on the environment around it. Okay. Any other questions? Okay. For liquid, the two things you need to know is that a liquid has three things. The first thing is that a liquid has definite volume, which means no matter where you put the liquid, it's going to have the same volume. It has an indefinite shape, which means that the shape can change, like if you move it from a glass to a different container. The shape of the water will change, but the volume still stays the same. And particle arrangement is the third thing you need to know. Um, in liquids, the particles are close together, but they can move around each other because they have like a mediocre attractive force between them, and they're able to flow. And then examples of liquids are water, milk, and liquid that you like, gas, for example, that you fuel in your car, stuff like that. Any questions on liquid? Okay. So the last state is gas. Gas has no definite shape. That means it takes the shape of whatever, like the container, just like water does. Um, and it also has no definite volume. It can take up, depending on the environment that it's in, it can take up a lot of volume or it can take up a little bit of volume. And gases have really widely spaced particles. That means the gas particles are very far apart from each other. And also, a really important thing to know about gases is that the particles, when they move around very fast. But in liquids, because there is still a attractive force between them, they move around a little bit slower. Does that part make sense about how fast they move? Okay. And examples of gases are the air we breathe. What's the air in our atmosphere is a mixture of a bunch of gases. Nitrogen is a gas, oxygen is a gas, um, and your stove, if you have a gas stove, then your stove is fueled on gas. And the atmosphere, like we talked about. Okay, no questions on gases? Okay, so because we talked about the main states of the three main states of matter, we're going to talk about what happens when how can we like change the state of matter, for example. And throughout the whole time, um, take the example of water and see how water changes state because like someone mentioned earlier, water is a very unique element or a very unique compound. Okay, so matter can be easily changed between the phase transitions. That's a term you guys need to know. And it can be easily changed. Well, not easily changed. It can be changed. So the first way of changing matter is by melting. So when you change from a solid to a liquid. So for example, when you have an ice cube, the ice cube is solid and it can change to a liquid by melting, changes to water. I'm sure everyone's seen that happen. They've seen the experience. And so how does that happen? When any type of solid, when it's heated, it gains a lot of energy, which means that the particles in the solid start moving around. And when they start moving around, they become liquid. And there's a specific temperature for every element. It's a different temperature for every element. And it's at that temperature, like you have to heat it that much to get it to turn into a liquid. So, for example, when ice is heated, the particles in the ice, they start moving around because heat causes particles to move around. And when it reaches a certain temperature, then that ice will turn into a liquid because they're moving around so fast, like this. So the solids particles start moving around and they turn into a liquid. Do you have any questions? No? Okay. So the next state of change we're going to talk about is freezing. So again, I'm sure you guys have seen freezing before. So freezing is from a liquid to a solid. So for example, when you freeze water in your freezer, it turns into ice. So it turns from a liquid water to ice, which is a solid. This is the opposite of melting. And freezing happens when a liquid is cooled. When you cool down a liquid, the particles start losing energy, which means they start slowing down. And as they start slowing down, they start to form into a shape and it becomes a solid. So water freezes into ice when it's cooled. Any questions? Okay. The third change.
Wait.
Okay.
So they changes the state. Water. Okay. Cool water can cool something down, like something that's also a liquid, but that's hot, as like water turning lava into obsidian or stone. So it doesn't have to cool on by itself. It can use like other liquids to help, right?
Yeah, so for the example of lava turning into obsidian, what happens is because lava is so hot and like extremely hot, and if there's like cool water, because the temperatures are so different, the um the water will help the lava cool down, and when it cools down, it turns into obsidian. Good question. Okay, the third state we're going to talk about is evaporation. And evaporation is when you change a liquid to a gas. So when a liquid is heated even more, so like maybe you've noticed when you boil a pot of water, you notice that the volume of the water starts decreasing. That's because that water starts turning into gas. And so when the liquid gains energy through heat, the particles start escaping into the air and they start moving faster and they start becoming a gas. And this happens at, so every liquid has a boiling point. Just like when you turn a solid to a liquid, there's a melting point. When you turn a liquid to a gas, there's a boiling point. And the boiling point produces the gas. Any questions on evaporation? No? Okay. Um, the fourth state of matter is condensation. So this is when a gas turns into a liquid. It's the opposite of evaporation. And basically what happens is the gas starts losing its energy. So as it loses energy, the particles start slowing down. And when they slow down, they start becoming like a liquid. And for example, if you ever like look at steam on a cold window, it's because that's an example of condensation. Any questions on condensation?
Okay. Okay. The water cycle. Let's just skip to the water part, the evaporating part. The water evaporates into a gas, right?
Yeah.
Then it turns into a cloud. It's then it gets so heavy and gets to move around more freely. Then it starts to rain. So is that like how gas turns to liquid? Because that's
Yeah,
what I could
yeah.
think of.
That's an example of how gas turns into water droplets is through condensation. Because the gas starts to lose its energy, the particles slow down, so it turns into liquid. Okay. If you have any other questions, please put them in the chat. Um, okay. The fifth phase transition we're talking about is sublimation. So sublimation is when you go from a solid to a gas. So basically, sublimation occurs when you skip the liquid stage. You go directly from the solid stage, which is order, to the gas stage, which is a bunch of particles moving out really fast. And there are some substances that can do this. Not all substances can skip the liquid stage. Um, so an example of this is dry ice. So dry ice goes through which is solid carbon dioxide. It goes through sublimation when it's at room temperature. So it turns from this solid brick to gas right away. Have you guys ever seen dry ice in action? Maybe you've done a science experiment, or maybe you,
Yes.
yeah.
I've seen it in experiment. Sun drops into water and it starts to turn gassy, like carbon dioxide. I think it's what it is.
Yeah, carbon dioxide. So, what happens is dry ice, if you put it in water, it does the same thing, um, probably faster. But if you expose it to room temperature, it also sublimes. Okay, any questions on sublimation? Okay, so those were the 5 stages we're going to talk about. So now I'm going to show you this chart, which is very important. Oh, I forgot to mention one. Oops, I don't think I put on here. The sixth phase transition is deposition, which goes from a gas to a solid. So it's when the particles slow down so much that they turn into a solid.
What element does that? Because I don't know anything that does that.
Um, hmm. I'm not sure of the specific elements off the
Well,
top.
if carbon dioxide can change from a gas to a solid, maybe it can change from a solid to a. I mean, if carbon dioxide can change from a solid to a gas, maybe it can change from a gas to a solid.
So carbon dioxide, think it can, um, I don't think that carbon dioxide can go through deposition. Let me check. Okay, yeah. So, solid carbon dioxide, which is the dry ice, um, usually goes through sublimation. I don't think it can go through deposition. But some elements that can go through deposition are like iodine and there's a bunch of like complicated elements. So you won't see deposition very often in like daily life. But there,
So can you show us some pictures of the elements that you said?
yeah, for sure. Let me pull that up. Okay. Iodine looks like this, and it's a pretty cool element. Let me see if I can find a cool video to show you guys about how iodine goes through deposition.
Iodine is a gray solid.
Hmm. Okay,
I can't see your screen.
yeah, I think this is a cool video. So
Oh, I can see it now.
here's an example of iodine. So it can sublime, which means turns from the solid that's in the bottom of the beaker, turns into this purple gas. And likewise, when this purple gas is like cooled down, you can see that this person's putting ice on iodine gas. It cools down and it'll turn back into a solid. So you can see that it starts turning back into a solid like this when it cools down. Does that make sense? Is that a good example?
Yeah.
Okay, cool. back to the lecture. Okay, so a phase transition. So this diagram is very, very helpful. Basically, you have these three areas. So this blue area is for solids. This purple area is for liquid. And this brown area is for gas. So this shows that the solid, to turn into a liquid, it goes into melting. It melts, and then for a liquid to go into become a solid, it freezes. Similarly, if a liquid wants to turn into a gas, it goes through evaporation. Evaporation is also known as vaporization, which is what they have on this chart. For a gas to turn into a liquid, it has to go through condensation. For a solid to turn into a gas, it has to go through sublimation, which we talked about. And a gas to a solid is deposition, like we looked at with iodine. And so we know that you can change matter, you can change the phase of matter by increasing temperature and okay, I got a message that someone can't hear me. Can everyone else hear me?
Yeah, I can hear you.
Okay. Okay, if you can't hear me, it might be something on your end. Oh, okay. Let's see. Nicole, I think it says you're connecting to the audio, so I don't think you've connected yet. Here, let me. Okay. Okay. So for the phase transition, we talked about how temperature can change a object from different phases. And but another way to do this is with pressure. If you increase, for example, if you have a gas, so which would be this purple. So here, I'm gonna annotate on the screen. So imagine if you have a dot right here. How can I change it to, looking at this chart, how do you guys think I can change it to a liquid? Because if I if I change temperature, it's going to go either to a solid or it'll go this way and it'll stay a gas. How do I change it to a liquid? Does anyone have any ideas? Sorry, I can't really hear you. Could you say that again, please?
So when gas it starts to stop, it cools down a little bit, it turns into a liquid.
Yes. I mean, that can be an example, but I'm talking about this particular instance where right here on this dot that I'm drawing, how do I turn it into like a dot here, for example? Because if I change the temperature, it'll only go to solid or it'll stay a gas. But to change it to a liquid, what I have to do is I have to increase the pressure. So you can change matter, the stage of the phase. You can change the phase of matter by increasing or decreasing temperature or by increasing or decreasing pressure. So it can be either one. And for this specific instance, you would have to increase the pressure because otherwise you can't turn it into a liquid. It would turn into a solid. Does that make sense? I know that's kind of tricky. Any questions?
How does pressure change it?
I'm sorry, can you
How does pressure push it up to the liquids? How does pressure is, I mean, it's like pushing it together more clumply.
Yeah, that's a good question. So pressure changes because of density, which is again related to temperature. So at the end, everything comes back to temperature. If you have like a gas, for example, in warm, if you move a gas to warm air, for example, then because warm air is less dense, the molecules between in gas will be pushed apart, and that means that they will the pressure will in the pressure will increase. Does that make sense?
Can you repeat it one more time? I didn't get it.
Sure. Okay, let me try to maybe say it in a better way. Pressure changes when air density changes. So, for example, if the air is more dense, then if it's like there's a great air density, that means that the pressure will be greater. But if the air density is lower, that means that the pressure will be lower. Was that a better explanation?
Yeah.
Okay. Okay, back to the phase transition. As you guys can probably notice, there's two things on here that we haven't really talked about yet. The first thing is this point right here. This is called a triple point. So, what is a triple point? A triple point is basically it's the point at which all three stages of matter exist. That means if you have like a pot of water, for example, and you adjust the temperature just right, and you find the exact temperature, that means at that exact temperature, you would have ice, liquid water, and gas at the same time, which is pretty cool.
What does that mean? I mean, how does a gas turn into a solid and a liquid at the exact same time?
Because of the temperature. So the temperature is just right, which means that the temperature is exactly 0.01 Celsius, I believe, which means at that temperature and at the exact pressure. So if you go back to this chart, at the exact temperature right here and at the exact pressure, when the environment is that way, that means all three of the stages of matter exist together.
As one thing.
Sorry, do you have a question?
So is it like every single thing mixed together, or just like one thing but can change the next thing to the next thing, and that's where it starts?
No, so what happens is all three of them exist at the same time. So for example, if you had like a bucket of water, for example, and you were at triple point, which means exact temperature, exact pressure, you would have a little bit of ice, you would have a little bit of water, and a little bit of gas at that point. So they would all exist at the same time.
So what would that look like?
Okay, this is a good question. I can actually show you a picture. So a picture is this. This is triple point of water, for example. Right here, you can see that there's liquid, which means there's water. You can see that there's ice, and also within this tube, you can see that, well, you can't see it, but there is gas within this tube. So that's what it looks like when water would have a triple point. Does that make sense?
Yeah. But can other things turn into a triple point or just water?
No, other substances can can have a triple point. I think that all substances have a triple point. So not all substances, but a majority of substances do have a triple point. So if we want to look at a triple point of nitrogen, for example, nitrogen was one of the elements that does have a triple point, which means in nitrogen, all three phases will exist at once. So to answer your question, not all of them have the same, do not all of them have a triple point, but a majority of them do. Okay, any other questions about triple point? Okay, the second part we need to talk about is critical point. Critical point is right here on the phase diagram. And you can see that critical point is between liquid and is between gas. And so you can see here that most of the time along the phase chart, there's this like dark border which separates all the phases. But after the triple point, you can see that there's no border, right? It's empty. So that is because critical point is when there's basically, it's like beyond the critical point, you cannot distinguish liquid and gas. They become the same. So an example of this is when you heat water, eventually the water will boil and it'll turn into steam. But if you keep like increasing the heat and the pressure, there's a point where you can't tell if it's liquid or gas anymore. It's a mix, it's like something between liquid and gas, and you can't distinguish the difference anymore. And it's just one substance. Does that make sense? And critical point, as you can see in the chart, only exists for liquid and gas. It doesn't exist for solid. Only liquid and gas. Beyond that point, if you increase temperature and pressure beyond that point, you can't distinguish liquid and gas. Does that make sense? Any questions? No? Okay, well, let's see now if you guys actually understood. We're gonna play a quick Kahoot, and then I'll let you guys go. So if you guys could open up Kahoot.it while I pull up the screen, that would be great. Okay. Almost there. Okay. If you guys could join the Kahoot, that would be great. If you guys have any questions, please send me in the chat right now, and it would be a great time to ask questions. Do we have to join the Kahoot? I really recommend you join the Kahoot because it's gonna help you. It's gonna help you determine what you need to study and what you know and what you need to work on a little bit. So I do want you guys to join the Kahoot, please. Okay, are we waiting on anyone? Is anyone having difficulty trying to get in the Kahoot? Okay, I think we're waiting on Jaden. I think Tony's in, Tim's in, Nicole and Edwin. If you guys could join, that would be great. Okay, we have Jaden, and I think we're just waiting on Nicole and Edwin. Okay, do you guys have any questions before we start the Kahoot? Any clarifying questions? Okay, I'm going to start the Kahoot now, and then if you haven't joined, please, if you can join in during the game. Okay, everyone should be able to get this one, guys. Three and two.
This is a poor choice of words.
Okay, looks like everyone got it. Okay, the other three had ice in them. Ice is not a state of matter. It is type of matter, but it's not a state of matter. Closely packed. Good job, guys. Okay, yeah, so it's false. In liquid states, the molecules they are packed together. They're just not very close to each other. So they do have a volume, which means that they're sort of attracted towards each other. Here. Okay, in a solid, particles are very closely packed. In a liquid, they're loosely packed, and in a gas state, they're not packed. Okay, pretty cool, pretty fast. Looks like everyone knows this stuff. And then we're going to get into the harder ones pretty soon. Okay, again, an easy one. Good job, guys. We have Anna on top. Okay, so false, matter can change states, which is the six, and we talked about the 6 ways it can change state. Okay. A good example of this would be ice. When ice changes to water, what does it do? It melts, right? So that's the correct answer. Okay. This one is kind of hard, apparently. So a liquid to a solid. So for example, again, you can think about water. When water changes into ice, how does it change? You freeze it, right? That's what turns it. That's what the phase change is called. Okay, Anna has a streak of 9. Pretty good. Okay, I think almost everyone got this one. Liquid to gas is evaporation. Okay, I think this one is harder. Gas to liquid is condensation. So you can think about how when we talk about the water cycle, we say that gas turns into rain through condensation. Okay, sublimation is when you change a um yeah, Nicole, go ahead and you can leave. It's okay. And so sublimation is when you turn a solid to a gas, and we talked about dry ice as an example, how it turns from a solid to a gas and it sublimes. Okay, yeah, triple point is when all 3 of the states of matter exist at once, and triple mean is like 3, so that's how you can think about it. And it has an answer streak of 13. Cool. Okay, everyone got this one. Good job. Okay, let's see who's on the podium. Very cool. Good job, Anna, and to everyone who's on the leaderboard. Um, so, there's today's homework is going to be optional. You don't have to do it, but it will help you because I know today's lecture was a little bit easier than last time's lecture. So, there's a worksheet. It'll be on Google Classroom, and there'll be a short assessment at the beginning of next class, like there was today. So if you guys want to do the homework, please turn it in, and thank you for coming. Bye.
Bye. See ya.
Bye.